Hello. So I'm gonna walk through my code for the M5 Final Hackathon. So in cell one, I just imported the libraries and load the datasets. And in cell two, I start with the exploratory data analysis to understand the data set structure. And here we can see that the data types, variable types, and summary statistics. And data set contains a large number of financials and demographic variables describing loan applicants, such as income level, employment history, and previous credit behavior. And in cell three, I analyzed the missing values across the data sets. And as shown in the visualization, several variables contain missing values, which is common in real financial data sets. And in cell four, um, another important observation is that the imbalance in the data set. So as shown in the chart, um, non-default cases significantly outnumber the default cases, and this imbalance means that the accuracy alone is not a reliable metric. So therefore, throughout the modeling process, I rely on additional metrics such as processing, recall, F1 score, and RLC AUC to better evaluate the model. And next, I explore the relationships between variables using the correlation matrix. Um, this helps identify highly correlated features that might introduce the redundancy in the model. And understanding correlation is really useful for feature selection and helps reduce potential multicollinearity issues. And after building the initial models, I analyzed the features' importance to identify which variables contribute most to the predictions. So, as shown in the plot, several financial indicators relate to income, credit history, and repayment behavior has strong influence on default predictions. And feature importance helps improve the transparency by showing which factors drive the model's decision. And because the data set contains many features, I also applied the dimensionality reduction techniques to capture the main structure of the data while reducing the complexity. And this step helps simplify the model and can improve the computational efficiency without losing important informations. And next, I evaluate the model predictions using a confusion matrix. So the confusion matrix breaks the prediction into four categories, the true positive, true negative, false positives, and false negatives. And in the credit risk modeling, false negatives are particularly costly because they represent the cases where the model predicts that a borrower will repay the loan, but the borrower actually defaults. And then to evaluate a model's performance, um, more comprehensively, I also calculate several metrics, including accuracy, precision, recall, F1 score, and ROCUC. Using multiple metrics helps provide a more balanced evaluation of the model, especially in imbalanced classification problems like credit default prediction. And moving on to the ensemble method. Here's to improve the predictive performance. I also applied this ensemble learning methods such as random forest and other tree-based models. So the ensemble models combine multiple decision trees and often achieve better performance because they can capture nonlinear relationships and interactions between features. And to further optimize the model performance, I use the cross-validation and hyperparameter tuning. And cross-validation helps ensure that model generalize well to unseen data, while the hyper parameter tuning also searches for the best combination of the model parameters. And this process improves both the stability and prediction power of the model. And I also experimented with a neural network model. The neural network can capture complex patterns in the data and sometimes outperform the traditional models. However, because neural networks are less interpretable, additionally, explainability and the methods are needed to understand their predictions. And just here to improve the interpretability. I applied the SHAP values, which explains how each feature contribute to a prediction. And in this SHAP summary plot, we can see um, both the importance of feature and how different values affect the predicted probability of the default, and SHAP provides a transparent explanation of model predictions and helps ensure that decisions made by the model can be understood and justified. And this is especially important in financial applications where decisions must be explainable to regulators and customers. And for the responsible AI principles discussed here. First, I improved the transparency by using the interpretable methods such as feature importance and SHAP explanations. And second, I addressed the fairness and bias considerations by carefully evaluating model errors, including false positives and false negatives. And monitoring these errors helps ensure that the model does not disproportionately affect a certain group of applicants. And third, I evaluated the model performance using multiple metrics rather than just relying on accuracy. And this helps ensure the balanced decision making and reduces the risk of biased predictions. So together, these steps helps ensure that the model follows key responsible AI principles, including transparency, fairness, and accountability. And finally, talking about the cost-sensitive decision analysis. Yeah, I conducted this analysis to connect the model predictions with the real-world financial decisions. So in credit lending, different errors have different consequences, and improving a borrower who later defaults result in financial loss, while rejecting a reliable borrower leads to missed opportunities. And by assigning different costs to false positive and false negatives, we can evaluate the expected financial impact of different decision thresholds and select a strategy that minimizes the overall risk. So I think overall, this project just demonstrates how machine learning can be applied to credit risk prediction while also adhering to responsible AI principles. And by combining the predictive modeling, interpretability techniques such as SHAP, and fairness evaluation, we can build models that are not only accurate but also transparent, accountable, and ethically responsible. Thank you for listening.